Hey. Hey there, everybody. Hello, everybody, and welcome to another math video for you rock stars. Today, we're going to be talking about, are they proportional? These tables, graphs, and context. We got to be thinking about our scenarios, tables, and graphs, are they proportional? Okay, so what is a duck's favorite snack? That would be cheese and quackers. Wah. Cheese and quackers. Cheese and quackers, that's good stuff. All right, so today we're going to determine whether a proportional relationship exists between two quantities when we're given tables or context or graphs. Okay, that's the goal. So is it proportional? We know that there's ratios out there, but does a ratio compare to another ratio and make it proportional? Well, we got some ways to figure that out. So let's just review proportional relationships first. So in order for a proportional relationship to be proportional, it's two variables if the ratios of the variables are equivalent. So think about them as fractions. So if I had two different ratios and I simplified them down to the simplest terms, those fractions would have to be equivalent. They'd have to be simplified to simplest terms, okay? That's what makes them proportional. So in other words, if I multiply the top by something and the bottom by something different, not so proportional. Okay, they must be equivalent fractions. So here's 1/2, okay? And in order for it to be proportional, we have to multiply the top by 10, which means we have to multiply the bottom by 10, and that will give us 10/20. And so those are proportional. 1/2 and 10/20 are proportional, okay, because they're equivalent fractions. We multiply the top and bottom, or we divide the top and the bottom by the same things, okay? And then when we're talking about proportional relationships, we only use multiplication and division. We're not talking about additive relationships, okay? Okay, so if you're given two ratios and are asked if they are proportional, test to see if they're equivalent fractions. That's the first thing. So if they just give you two ratios, here's one, 2/3 and 8/15. We have to see if they're equivalent, okay? So what did we do to the top to get to 8? So you see how we had a 2 and we moved over to the 8. Well, we multiplied by 4. So then we have to test to see if this is a proportional relationship. We have to multiply the bottom by the same thing. And we can't in this scenario, because if we multiply the bottom by 4, we would get 12 over here. So actually, we multiply the bottom by 5, and we multiply the top by 4, which means this is not a proportional relationship. They have to go, the top and bottom have to be adjusting by the same rate. In this case, it would have to be both times 4 or both times 5. Okay, so let's think of a scenario or something in context. So a store sells bags of apples. 4 customers put how many bags and apples they bought into a table. Okay, so here we go. So one of them had a bag and they put 4 apples in their bag. Another person had 2 bags, they put 8 apples. Another person had 3 bags and they had 12 apples. And another person had 5 bags and they had 20 apples. So what we're going to try to figure out is this table a proportional relationship. In order for it to be proportional, all parts of the table have to be in proportion. So there are 2 ways to check this. Okay, we can look at the ratios first. We could say, how did I get from this bag to apples? We can say, well, I multiplied by 4. If I have 2 bags and I multiply by 4, I have to get 8. Yep. Remember, all these have to be the same. What's 3 times 4? That's 12. That worked. And what's 5 times 4? That's 20. So that worked. Okay, another way you can check it is let's see if we have equivalent fractions. So we can say, what did I do to the bottom? I multiplied by 2. So right now, when you're thinking about this, we're only comparing 2 ratios or 2 fractions at a time. Okay, so for that one, we're going from 4/1, comparing it to 8/2. Okay, so we multiplied the bottom by 2. So in order for this to be proportional, we have to multiply the top by 2. What's 4 times 2? It's 8. That worked. Now we're going to go from the unit fraction over here, and we're going to compare it to that fraction. Okay, so what did I do on the bottom there? I multiplied by 3. So that means on the top, I have to multiply by 3. What's 4 times 3? It's 12. All right, so that one works. And then finally, we compare our unit fraction to the last fraction. On the bottom, we multiplied by 5. On the top, what's 4 times 5? It's 20. So in both of these ways that we checked it, it worked. Okay, let's look at another one. Jason went on a 5-day road trip, and he put his data into a table. So every day that he was there, he put how many miles he had covered, okay? So on day 1, he went 4 miles. On day 2, he's up to 8. On day 3, he was up to 15. On day 5, he was up to 20. So is this ratio table proportional? Well, there are 2 ways to check. First, we look at the ratios. I multiplied by 4. That works. Second one, I multiplied by 4. That works. Third one, I multiplied by 5. If they are not all the same thing, it is not proportional. I could also look at the equivalent fractions. I'm comparing the first 2, multiplied by 2, and multiplied by 2. Ding, ding, ding. Multiplied by 3, and multiplied by 3.75. That means it doesn't work. This bottom one multiplied by 5, multiplied by 5, but because this one is not in proportion with the rest of them, it is not a proportional table. Okay, so it's a pretty easy way to check. Now, what about graphs? Graphs are a lot simpler, actually, because there's a couple of quick rules that you can learn. So a proportional relationship can be shown on a graph as well. And there are 2 basic rules for knowing if a line on a graph is proportional. Okay, first of all, it has to start at the origin. A graph has to start at 0, 0, right at the, and if you're thinking about what's an origin, here's our graph has to start right in the middle there, okay? That's the first thing it has to do. And the second thing, it has to be a straight line, because for every one we go up, we're going the same thing at each one. So if we're climbing steps, we're going to form a straight line. If you plot points, you can kind of see that, all right? So it has to start at the origin, and it has to be a straight line. Let's see some examples. Are these graphs proportional? Okay. Starts at 0, check, and it is a straight line. So that is proportional. Let's look back at what I told you about has to be a straight line. So this one we're going by 5 up to 6, 10 up to 12. So we went 5 and 6, okay? And then we went 10 and 12. See how they're doubling? And then I go all the way to 15 to 18. All right, so that means we multiplied by 3. And the next one would be 20 and 24. Okay, so that one works. Yes, that is proportional. It starts at the origin, and it is a straight line. Check. What about this one? All right, cool. We got a straight line. Does it start at the origin? No, it does not. But it is a straight line. This is not proportional. Both of them have to work. Whoa, whoa, what in the world is this? Well, this does not start at the origin, and it is not a straight line, so that one is not proportional. All right, so is it proportional? Let's fill out our little blanks. For a table to be proportional, the ratios must be multiplied or divided by the same rate. So in other words, we're multiplying either up or down. If every member of that table has to be multiplied by 4 or by 3 or by 2, whatever that number is, it has to be the same. The other way we can do it, for a ratio table to be proportional, the ratio fractions must be multiplied or divided by the same rate. It's the same thing. So when we had the table, we multiplied the top by 2, we had to multiply the bottom by 2. If we multiply the top by 6, we have to multiply the bottom by 6. All of those have to work out to be equivalent. And then finally, for a graph to be proportional, it must pass through the origin. So it has to start at 0, 0, and it must be a straight line. Good work, good work, good work, good work. To have around. Anyone know? Oh, that would be a dandelion. Dandelion.